Hello and welcome back once again. We're coming to you from the downtown business district, and as you can see here we have a fair bit of traffic. Today's topic is types of errors encountered in statistical tests of hypotheses. This material is covered in your workbook and textbook on the indicated pages. We want to acknowledge the development team of Brad, Spencer, and Amanda. We choose an illustrative problem involving a drug with the name dioxazepam. It's used in the treatment of an age-related disorder among seniors over 55 years of age. It's prescribed in liquid form, potency of 5.00 milligrams per cc, and standard deviation 0.12. And we want to carry out a test to see if the potency is significantly above 5.00. We're going to do a test of hypothesis here. The idea is that if it's significantly above 5.00, it can cause a severe reaction, possible death. So we'll have to try and prevent that from happening. We take a sample in 28 vials, and we want to test at a level of 5%. The null hypothesis, the mean not significantly above 5. Alternative, the mean potency is significantly above 5. We're going to carry out the test, and we're going to examine various types of errors associated with the decisions involved. Now, assuming H0 is true, mean is equal to 5, we have this distribution of sample means here, centered at 5, and sigma sub x bar is 0.0227. We're looking at a 5% one tail, and the Z critical is 1.645. This gives rise to an x bar critical of 5.037. So if x bar is above 5.037 or z is above 1.645, we're going to reject H0. Otherwise, in this region to the left, we're going to fail to reject H0. Now, if H0 is actually true, and we conclude, so this is our conclusion up here, if we accept H0 as true, then we have a correct decision. We accept something as true when in actual fact it is true. This is a correct decision, and this is the probability of that happening is 95%, or the area under this curve here. On the other hand, if we reject the claim, this is an error. Rejecting something that's true is called type 1 error. The probability of that happening is 5%. Now we're going to look down here. If H0 is false, and if mu is actually 5.05, so we're saying if 5.05 mean is in effect, then this can cause severe reaction. We want to test if we can acknowledge this. So this diagram above is wrong. In fact, if H0 is 5.05, this curve at the top here is placed at 5.05. Standard deviation 0.0227. Now here's the thing, that this criteria line joins the two together. So on the left of this line, we're failing to reject H0. On the right of it, we're rejecting H0. This then, we accept H0 as true, we accept this statement up here as true when it's actually false. And this is called the type 2 error or beta error. On the right hand here, if we reject H0 when it's false, this is a correct decision. Now we need to look at the area of this purple region, this red region here. This is your beta error. The cutoff there is 5.037, same as above. And we're looking at the probability of getting an x bar to the left of this black line, 5.037 minus the center, 5.05. And that Z score is minus 0.5727. P probability is 0.283, or 28.3% chance of erroneously accepting H0 as true when it's false. This is the type 2 error, 28.3%. A correct decision then is 71.7%. If this product is put on the market with this probability, 28.3%, it could bring about massive damages. Well, that's the end of presentation 8.8. We ask you to review once again and go on to presentation 8.9.